I'm Kindson the Tech Pro, and today we are going to be looking at Mergesort. So my idea is for you to understand the concept. So on the black screen here, I'm going to explain the concept, and here I'm going to actually be writing the program and explaining the program line by line to you. So the key thing is for you to understand how to implement it. If you want to understand more about the concept, you can actually read and understand the concept. Although I'm going to explain it, but the key thing is for you to translate this concept into Java code. Therefore, I would like to remind you to subscribe to my channel. So click on the subscribe button below this video. In that way, you kind of motivate me to continue making this lesson for you. If you have any particular problem or coding problem you want me to solve, let me know by leaving it in the comment box below this video. Alright, so let's see how it works. So Mergesort is a procedure that takes logarithmic time. So it takes order of n log n time. So it's really very good. So how does it work? The first thing it does, let me just lay out the steps. One is splits into two halves. The next thing is to sort each half separately, and finally merge the two halves. Okay, and of course you know that in this step 2 we are talking about it uses Mergesort to merge this to sort the Mergesort to sort the two halves. So let's apply Mergesort in this array we have here, and let's exactly understand how it works. So the first thing we do is to split this in two halves. So we choose a splitting point of this place. So the first half of the array will be this, and the second half of this array will be, sorry, I will not take that. The second half of this array will be something like this. I think this is better right now. Alright, so we have, for each of them we have 3 items. So we go ahead to put in the values that are already there. For now we've not sorted anything, so let's just put 6, 2, 3, and we have 5, 1, 8. So the next thing we want to do is to Mergesort on each of them. So if we Mergesort on 6, 2 and 3, so we are going to have Mergesort is simply sort it using Mergesort, and normally, and this is a recursive procedure. So we are calling Mergesort recursively. So it means that here we are also going to perform Mergesort by also doing a split. So, but now this is how it works. So after sorting it, we have 2, 3, and 6. After sorting these, we have 1, 5, and 8. 1, 5, and 8. And the final step is to merge the two halves. So let me use a different color pen. So let's see the merge procedure. You need to be careful with it. So let me show you how the merge works. And we say you merge the two halves in sorted order, right? Yeah, so let's see. So to make the two halves in sorted order, you continuously or repeatedly compare the item here and the item here. So if you compare 2 and 1, you find out that 1 is less, then you place 1 in here. Then in the next thing, you place 2 in here. You compare 5 and 3. 3 is lesser. This is 5. This is 3. You then place 3 here and place 5. You compare 6 and 8. 6 is less, and 8 follows. And check it out that everything is solved. But now, assuming the halves are disproportionate. So after sorting, after doing the comparative sort, then you simply copy across whatever you have to the end of the array. All right, so let's go ahead to implement it in Java so that you appreciate and enjoy exactly how it works. So the first thing we want to do is to Mergesort, to call Mergesort on this array. So we have a function called Mergesort that we are going to call recursively. So public static void Mergesort. So now you give it the array and give it the starting position and the ending position of this array. So let's start from 0 and we sort first the name of the array. So we have public void Mergesort. So it takes an int array. Okay, so this is the overall function that just for the first time it takes an array. So now the real function is called Mergesort. This is what I was trying to write. The array starting from 0 all the way to the end of the array, which is the array that length -1. Array dot length. Permit me. Okay, let's give a second. I think it's freezing up. Okay, perfect. Array dot length. Permit me to just use ARR because so that we save some space. ARR dot length minus -1. So ARR dot length -1 is the last element of the array. So basically, this is what happens in Mergesort. So Mergesort, to give it the array, it calls Mergesort on the array, right? Okay, so let's now write this function, this actual function that is called, that is going to merge the half of the array. So this function that we are writing now is going to take an array, start from one index to the next index, and then performs Mergesort. So you need to actually understand recursion for you to appreciate exactly what is happening. So we are going to say public static void Mergesort. It takes an integer array, as you know, and let's use the same ARR. So int left, int right. So once you understand one of these merge algorithms, sorting algorithms, for instance, quicksort, we have Mergesort, then most likely other ones will be easy. So if you look at the previous problem we solved quicksort, and it's similar to the procedure is actually similar, but the algorithm is completely different. All right, so now the first thing we want to do is to define, to understand that we are sorting from here is the left and here is the right. Okay, so maybe I can use it from here as well. So we are moving from left to right. So far as the left has not become greater than the right, we continue to sort. But if the left have become greater or equal to the right, then we stop sorting. All right. So we are going to say if left is greater than or equal to right, what we are going to do is to just stop sorting. So we just return. All right. However, when left is not equal to right, it means that we can continue sorting. So we are going to first find a mid element, a middle element. Is going to give us a middle equal to, of course, you know that is left minus right, left plus right over 2 divided by 2. All right, so this is the mid element. So let's just use a simpler name. Let's call it mid. All right. So we go ahead to Mergesort the first half. At this point, we actually have achieved. If you look at this place, we have this middle point at this point. So if we have 6, we are saying if we have a left plus right 0 plus 6 over 2, right? 0 plus 6 over 2, which is 3. So we are saying that we are now going to take the carry out merge sort on the first half. So let's do merge sort on the first half, meaning from 0 to mid, right? So let's merge sort from 0. First we are going to take the array, because it's the same array here, from 0 to mid, so actually from left. So left is actually 0 at this point, from left to mid. So we also do the same thing in the right half, the array from mid plus 1 at this time, mid plus 1 all the way to right, good. So this is how you perform the second merge sort on the other one. And finally, we are going to merge the two. So just call a function merge. So this function is going to take an array, the array, and just merge the two halves. So it needs the left half, the left end and the right end. So half left and right. All of this doesn't make much sense to you. Just try to follow along. I'm going to clarify because right now we still have to write this function called merge to be able to actually merge the two arrays. So for now, since I am running out of time, I'm going to continue in the next part. For now, this is actually exactly what happens in Mergesort. We are going to divide into two, split into, sort or merge sort each half separately, and then merge the two halves in sorted order. So I'd like to remind you to subscribe, and then we are going to see in the next part as we continue to write or to implement merge sorts.